All right, here is the second part of section 5.5. We start off with an example like this. The way we want to use this is we want to use a version of the base exponent property. And what that really allows us to do is to take a logarithm of both sides. When you take the logarithm of both sides, you write down your log and you put the whole expression in parentheses on both sides. This is very important. Now here, I'm just using log base 10. For all of these, you want to use log base 10 or you want to use the natural log. I usually use this one or this one. These are the logs that you have on your calculator. And so by leaving them in this form, it'll make it easier later on. So we take the log of both sides and then we use our power property, which brings our powers down front of the logs, both here and here. So we get to this step. Then you use the distributive property, where we're going to now multiply out what we have. So I'm going to do x times log 4, that's x log 4. And I'm going to do 3 log 4, and that's equal to minus x log of 3. Since we're solving for x in this case, we want to get x all on one side. So I have x over here. I'm going to bring this x over here. I'm going to bring this number, this log over here. So I'm going to get x log of 4 plus x times log of 3. And that's going to be equal to minus 3 log of 4. Now I'm going to undistribute my x here. So I'm going to have x times the quantity log of 4 plus log of 3. And that's going to be equal to minus 3 log of 4. Now, to get x all by itself, I'm going to divide both sides by all of this. And I'm going to get x is equal to minus 3 log of 4 divided by the quantity log of 4 plus log of 3. Now to evaluate that on the calculator, you just type that in. So I'm going to do minus 3 log of 4, close parenthesis, divide, open parenthesis, and then I'm going to do log of 4, close parenthesis, plus log of 3, double close. Remember, using these parentheses is really important to do it is exactly this way. Otherwise, you'll get incorrect answers. Pressing enter, I'm going to get negative 1.67. And that's it. There's another part in this chapter on quadratic forms. I don't think there's any homework questions on this, but you may have something where you have e to the x plus e to the minus x minus 6 is equal to 0. Now I know this looks like something really weird that you'd never see before, but this is actually the equation if you have a chain that hangs between 2 points. The equation that this is pretty close or a derivative of this type of equation. If you were going to build a suspension bridge, that's the equation that you would end up with. All right, now we're going to move on to solving log forms. First example we're going to look at is log base 3 of x is equal to minus 2. Again, we want to use the base exponent property, or we want to change the form. Here, if we change it the form to exponential form, this becomes 3 to the minus 2 is equal to x. Now you can type this on a calculator or recognize that's 1 over 3 squared, which is equal to 1/9. Another example. So we've got log of x plus log of x plus 3 is equal to 1. Here again, we're using the common log. So I'm going to use my powers property. So I'm going to bring these two together. So I'm going to get log of x times x plus 3. And this is using my product property that we learned in last section. Now I can change the form. Now it's a little bit weird because there's no base here, but remember that this is technically base 10. So if I change the form, this becomes 10 to the first power is equal to x times x plus 3. Now, multiplying this out, I'm going to get a quadratic. Subtract 10, that's equal to 0. And now you use your skills in factoring quadratics to solve this. Let's see, x plus 5 and x minus 2. So I'm going to get x plus 5 equals 0, or x minus 2 equals 0, and x is equal to negative 5, or x is equal to 2. You do have to be careful though, because when you take the log of a number, that number has to be greater than 0. You can't take the log of a negative number. So you just want to make sure that you check your answers. Here we've got minus 5. And if I put that back into this equation, I'm going to do log of minus 5. And that's a big no-no. So that one's definitely not going to work. But if I put 2 in here, that's going to be positive. 2 plus 3 is positive. So that's going to work. You don't have to do the whole equation out. Just make sure you're not taking the log of a negative number. All right, another example. So here we go. Another log equation. I'm going to use my quotient property to write it as log base 3 of 2x minus 1 over x minus 4. And that's going to be equal to 2. Now I'm going to change the form. This is 3 to the second power is equal to 2x minus 1 over x minus 4. So again, we're changing it from logarithmic form into exponential form here. All right, so now we just have to solve this. I'm going to bring this up over here. So I'm going to get 9 times x minus 4 is equal to 2x minus 1. 9x minus 36 is equal to 2x minus 1. 7x is equal to 35. X is going to be equal to 5. Again, you want to make sure that you're not taking the log of a negative number. So we're going to check 5 here. 2 times 5 is 10, minus 1 is 9, that's good. 5 minus 4, that's good. So it looks like we're okay for that one. All right, last example. Let's do the natural log of 4x plus 6 minus the natural log of x plus 5 is equal to the natural log of x. Here, I'm going to use my quotient property again. And so I'm going to write this as the natural log of 4x plus 6 divided by x plus 5, and that's equal to the natural log of x. I'm essentially going to change the form of both sides, but the effect it has is you cross out the logs. Now you can only cross out the logs if you have one log on this side and one log on this side. Can't cross off the logs here. That's no bueno. That's not going to happen. So you have to make sure you have just a single log on one side and a single log on the other. Now we could do 4x plus 6 is equal to x times, I'm going to bring this guy up over here. That's going to be x plus 5. I'm going to get 4x plus 6 is equal to x squared plus 5x. Again, we're going to have a quadratic. I'm going to get x squared plus x minus 6 equals 0. I'm bringing my minus 4x. 5x minus 4x gives me positive x. Subtracting 6 from both sides, get a minus 6 over here. Factor it out. X plus 3, x minus 2 equals 0. I'm going to get x is equal to minus 3. X is equal to 2. Again, we want to make sure that we check both of these answers. If we put minus 3 in for here, we're going to get minus 12 plus 6. That's going to be minus 6. So this one is not going to work. 2 seems going to give a positive result here and here. And that should be good. All right, good luck with these. And that's the end of 5-5.